Okay, so I said I'd show you the code. So I don't know if I've ever published this before, but I have a GitHub repository and it's here, you can see it. In here, click on Alleyway and I've got two projects. So the first one is the IR one, but the IR one is just a waste of time. Those SR105, 501 or whatever they are, they're crap. People say that you can put tin foil over them, or you can put a capacitor over, decouple it and all this stuff, but it's just too much messing about. So I'm using retractive switches now, which I think is easier. The code's easier as well. So int LED pin. I'm sure there's supposed to be a define there, but it doesn't matter. So define the LED pin. Now that's actually the base pin for the transistor. So we've got the collector, emitter and the base. If the voltage of the base is higher than the collector, then it basically shorts the collector and the emitter together, therefore completing the circuit and therefore powering the LED. So that's the base pin. Switch pin is the pin that the switches go to. So the switches are both connected to ground and then they're open. When you close the switch or when you press the switch, it completes the connection from ground to the pin. In other words, it pulls the pin low. So that's pulling switch pin 12 low. So when somebody presses it, it pulls the pin low. Otherwise it's pulled up. Okay. Bool LED on, that's because we store the state of the LED, so if it's on we store it, if it's off we store it, because otherwise there's no other way of knowing if it's actually on or not. So long light on hold, that's how many milliseconds you want to hold the light on for. So for me I've got it set to 60,000 milliseconds, which is of course 60 seconds. Last switch low. Last switch low is the last time the switch was pressed in milliseconds. I might have to deal with overflow and stuff here, I don't know, I'll have to look at that. Setup. Set the LED pin as an output pin. Set the switch pin as the input pull-up pin. I've already kind of touched on that. In the loop, right. So look at the switch state. So we've got a variable called switch state. Now that's digital read switch pin. So read the switch pin and see what it is. And obviously you get a higher or low. So it's pulled up by default, so it should be high, but when you press the switch, ground should go from the switches. There'll be a closed circuit from ground to the pin, and therefore it will read low. LED is on old state, so we get the LED is on the old state from before we take the new state, okay? Because we could change the state, and you want to know if something's happened with the LED, like whether it's on or off, so that you know to change it. Obviously, there's no point in switching something off that's already off. So, if not switch state, the exclamation mark there means not. So if not switch state, in other words, if it, let me just think about this now. So we get the switch state. That's saying if it's low. If the switch is low, or if the switch is pressed, then mark the current LED is on as true. LED is on. Last switch low is the time now. Record the time that it was pressed, which is now. If LED is on and the time now is greater than the last switch time plus the whole time, then we need to turn it off. In other words, it's timed down. So LED is on, false. Then we go, if the old LED state is not equal to the new LED state, in other words, we're changing whether the light is on or off in this particular loop, then digital write to the LED pin whatever the new state is. And then we delay 1 millisecond. And that's all of it. It's really simple actually. And that's the code I'm using for my Alleyway project. Hopefully this will be useful to you, and thanks for watching. Bye!